Well, why don't I start? So let me thank you for coming. I know everyone at this point of the conference has Mathematica fatigue, and so let me try and get you excited about this project, which I sort of think, like, why would anyone else but me be interested in this? And I think the selling points are, first of all, I'm going to show you what RLink can do, which is actually a lot, and it's very easy to use and very powerful. I think what I've got is a little bit of a Rosetta Stone project here, in which you can see how to do various things in R, and then also how to do it in Mathematica, and how to use some of the R package ideas as kind of a hint for some ways that we might make progress with Mathematica dataset objects. To also show you how you can handle, these are fairly large data sets that I'm going to be talking about today, and to see how things scale. And then, of course, you might also be interested in the Affordable Care Act itself, and it's a fairly important thing. And I think originally, this talk was going to be a little bit different because we were going to have data that was going to be released by the government in early October, and I was going to be able to contrast the rates that are available on the various healthcare exchanges with those that had previously been available. But I am now told that I know the data has not been released, and as a sort of a, I don't know, a kick in the pants, I think it's going to be released tomorrow. So doesn't do me much good. So this talk has morphed a little bit. Originally, I was going to talk about some testimony that I gave before Congress this summer on some of the financial stability issues in the Affordable Care Act. I'll still talk about that a little bit, but I'll also just talk about some very large data sets that are now out there just waiting to be mined. Data that we've never had before about the functioning of American health insurance markets. So with that, just to fill you in, one of the things that I was asked to talk about with Congress this summer was this issue of rate hikes. As some of you may know, there's a projection that the rate hikes for health insurance plans are going to be quite substantial this year. In Illinois, it's projected, for example, that there'll be about a 20 to 21% increase in gross health insurance premiums for people who are buying their policies on the exchange, and so the question is why? And so one of the theories that was being batted about was that this was due to the diminution of a subsidy program that the government's been running for insurers on the healthcare exchanges called transitional reinsurance. And so one of the things I wanted to do was to see, was that really a substantial factor in the price increases that we're projected to see? The short answer is no, but in order to do that, what I really needed to do was to get data on the expected claims under the Affordable Care Act. And since insurers don't tend to publish their claims data, they kind of regard that as proprietary, the source for this was a bunch of calculators that the government maintains in Excel spreadsheets. And so what I needed to do was to suck in those Excel spreadsheets, which are, of course, not in a format remotely nice for what I wanted to do with them, transform them, and then to use them in order to do the needed computations for how much was this reinsurance that's being provided to health insurers really worth. Okay? So in the course of that exercise, and subsequently, I ended up writing not a huge amount of code, but some code that might have some value for more than me. And this is code that basically does things like take CSV data and turn it into a Mathematica data set. It takes an R data frame object. R has data frames that it uses. How many of you have used R? Okay, so most of you know this. And it converts it into a Mathematica dataset object, and vice versa. We can go from a Mathematica dataset object and construct an R data frame, which can then be shipped back to R. And so one of the things I wanted to do for this project was to make dual use or hybrid use of R and Mathematica easier. Some of the other things I wanted to do is, are many of you familiar with R's dplyr package? Okay, it's a package for manipulating data. I think it's a fairly nice package. It's a friendly package. And so one of the things I wanted to do was kind of emulate that within Mathematica. And I don't claim that this has been, yes? Yes, I could. I don't claim that this has been particularly elegant or successful, and I've had some nice conversations with Tally here at the conference on how it might be done better. But if you're desperate and can't wait till Mathematica 10.4 or 11 or whenever this happens, this may give you some suggestions about how to do this sort of thing. You also may have seen a talk by Alan Cavuti, which was a sort of a parallel approach, kind of like the two people who discovered Neptune together, except nothing so profound. You can use either his code or my code, but there's a variety of things that are in here that I think might be of use to you. In any event, what this ended up trying to show, and there's a lot of cleaning up code here, which I don't think would interest anyone but the most die-hard individual, was a sort of a combination of use of R and Mathematica in order to conclude, when we got to the bottom line and joining various data sets together, there's a good old left join in R, there's a left join done in Mathematica, and by the time and then we had to merge in some other data, by the time we were all done with it, I was able to basically show that really, although the reinsurance is quite valuable to the insurers, there was not going to be that much of a diminution of it between 2015 and 2016 for many of the plans, such that it would really be responsible for the premium rate increases we're seeing. That is, this was sort of forensic work, you might think of it, as trying to isolate causes for the increase in premiums, and I think there's a fairly strong negative proof here that it's unlikely that in many cases that the diminution in the government reinsurance program is involved, and that there may be other factors that are responsible for the premium hikes. So that was kind of the summer project. Oh, the other thing, by the way, just so you know, is one of the things I wanted to see is this actuarial value calculator, which is being used right now to regulate insurers and the sales of insurance on the healthcare exchanges, is it even internally consistent? That is, they have various columns that are supposed to have mathematical relationships to each other. And so I probed this, and it turns out that it is not consistent, which gives me two levels of trouble. One is it makes me a little cautious about my initial conclusions, because they were premised on the government's actuarial value calculator being correct. And secondly, it just sort of worries me that we've got a fundamental instrument of policy here, which when you look at what it purports to do and do the computations independently, it does not match. And I've sent letters off to Congress about this and, of course, gotten no response. So, in any event, the project that I've tried to undertake since then is to look at some of these other databases that have been published recently. And these are things like very large databases on attributes of plans sold on the various exchanges, of which, as you can see, since 2014, there have been 49,972 plans. There are 126 attributes on each plan, and to see what we can find out about that data. There's also I assume this is all coming out of some gargantuan Oracle or SQL database with lots of related tables. And so they don't publish the whole data frame, they publish the pieces. And so one of the things I want to try to do is to put some of these pieces together and see what relationships we can develop, but also simply to do, I don't think in this whole talk I am doing anything fancier than multiplication, okay? It's just very basic, pointing your telescope at data that's never been seen before and trying to look at sort of what sort of insurance system, in fact, do we have. Okay? So there's a fair amount of the usual horrible cleaning that one has to do with data, which got me into the Mathematica type system, and just, things that people do that are dumb, like coding percentages as strings rather than as numbers. Okay, so then you've got to identify which columns have the percentages in them and turn them into numbers, or they can't spell yes and no consistently, which one might have thought was not a great challenge. But in any event, producing additional files that other people can use. So here's some things that we can see right off. We can see that there's been an increase between 2014 and 2015 on the number of issuers that are selling plans on the healthcare exchanges. We can see an increase, even if we take out dental plans, of which there are a surprising number, There's still an increase. We will see if that persists in 2016. My suspicion is that we're going to see kind of a leveling off of the number of insurers. We can break that down by state, see what's going on a state level. We can break that down by service area, which for an individual is kind of what's important. So that, for example, if you live in, I think this is Arkansas Service Area 2, what's important to you is that there may only be 2 plans that are available to you or 2 issuers that are available to you. And so you need to start to be concerned about the level of competition in those states. And for example, there are a lot of healthcare, as some of you may have read in the news, there are a bunch of health insurer mergers that are being proposed and trying to go through. And so if there are only 2 carriers, and those are the 2 carriers that are being merged, that might be of some concern to you. And here's a histogram showing, okay, how many issuers are there in each service area, both in 2014 and 2015. We can do the same sort of data analysis looking at metal levels. Some of you may know that these plans come in various gradations depending on how much they pay on average, with platinum being the best and bronze being the least valuable and catastrophic. And so we can see where has the growth in policies been. Some of you may know there are different styles of plans in the United States. There are HMOs and PPOs and EPOs and POSs. And we can also start to take a look at where the growth has been. And in fact, just have a side point, I think what we're going to see in 2016, and I think it's actually probably the most important development we're going to see, is I think we're going to see a leveling off or diminution in the level of number of PPOs that are being sold. Insurers seem to be losing money on PPOs, and therefore you're seeing, for example, in Illinois, Blue Cross will no longer sell you the same kind of PPO it sold last year. There's another cruddy PPO that it's willing to sell you, but not the nice one. So these are all things that we're able to do, and I think if you look through the code, which I won't, it's impossible to read code like this in a talk, but if you look through the talk, you'll see that I'm doing the same sorts of things in Mathematica and R, and you'll see how one can do it in either system. We can also look at there are different types of contracts that are available. We can see how those have been handled. Some of you may know that one of the new things in health insurance is tiering, in which if you go to the cheap doctor, you might get reimbursed for 80% of your claim, but if you want to go to the fancy doctor, you might only get reimbursed 60% of your claim. And so one of the things I wanted to look at is, has there been a growth in tiering? It turns out there has not been. Or this issue of, do you need a referral to go see a specialist? What's been the historical trend in that? How does that vary according to whether you have an EPO, a PPO, an HMO? Does it vary depending on what metal level plan that you have? And again, I will not pretend that any of this analysis is particularly sophisticated. It's simply database grouping operations followed by aggregation operations on the grouped data, although I will say that it is not often self-evident how to do that in Mathematica. And so this code, I think, has some utility in giving you some hints as to how, as of 2015, it might be done. Maybe in 2016 we'll have some better mechanisms. Any of you in wellness programs? So, okay, one person. These wellness programs are basically designed to induce you to either listen to things that will make you healthier or actually to engage in activities that will make you healthier. And if you do them, you may get it's usually articulated as a subsidy on your insurance premium. The other way of looking at it, of course, is that if you don't do it, then it's a tax on your insurance premium. And so one of the issues is some people are fearful that these wellness programs are a surrogate for bad old-fashioned underwriting. So for example, supposing the wellness program is you've got to be able to walk a mile in less than 20 minutes. People who have health problems are going to have greater difficulty meeting that goal, and so some people are concerned that wellness programs can mask medical underwriting, and there are all sorts of regulations that are designed to prevent that. But in any event, one issue simply is to what extent are wellness programs prevalent in the United States, and at least in the exchange plans, and for the first time I think we're getting a good handle on that. Anyone here subject to disease management? So another idea is that for people who have chronic and expensive diseases, we can start to, the insurer can throw responsibility for management of those diseases onto the individual, and if they are good people and comply with the program and take their puffers and take their blood pressure frequently, and I don't know what you do with pregnancy, but in any event, you again get some sort of reward on your policy, maybe lower cost sharing levels. And so one of the things I wanted to look at was the extent to which health plans were subjecting people to the disease management, what diseases were going to be subject to disease management, was there a trend in it, and so we can do fun things like make pie charts out of Mathematica data frames. What is this looking at? Oh, this is looking at prevalence according to type of plan and the like. And then finally, while we're playing with Mathematica graphics, one of the things we might want to do is to see whether there's any geographic dispersion in the use of things such as disease management. And so we can do certain operations, and here you can see me. Let me just stop for a second and have you take a look at this code. Not that it's great code, but it gives you a flavor, I think, of one way that you might want to write your data set processing operation. You'll notice a lot of use of postfix operators. I think that's, and that is sort of the R dplyr way of proceeding, is that you use these postfix operators. I think the reason that's attractive is that it in fact corresponds to the way that people think about databases. That is, it is sort of a procedural kind of thing. Take your data, filter out the ones that don't have some characteristic, then group everybody together according to some characteristic. Then for each of those groups, proceed to find out some aggregate statistic on some of the data contained in there. And so you can see this flavor of programming style being used here, and I think it's something that is a helpful way to go about things. In any event, we end up with the usual geo-region value plot, which does show some difference in the use of disease management throughout the United States. And I honestly, I'm not sure I detect a pattern. It doesn't seem to be particularly prevalent in the Southeast, in quadrants of the Midwest. It seems like Utah and Texas and Oklahoma and West Virginia love their disease management. Again, it's really there to illustrate, for one thing, it illustrates that health insurance is not a unitary phenomenon in the United States. There's a great deal of variation amongst the states and regions, and also simply as a way of showing you that you can integrate various parts of Mathematica together in ways that are kind of convenient to make attractive plots. Yes?
White space is there over some of the states. Does that mean there's either no data for them or they don't have these?
That means there's no data. For example, California is not part of the federal exchange system. They have their own exchange. And so the data I have is only for those states that basically report to healthcare.gov what they are up to. So I don't see New York in there, and there are other gaps.
Is it possible to get your database with this?
Yes, in fact, there should be in the materials for this session. I was told they're big, and so I think they were chunking through uploading them. But on Pathable, there should be all this data, okay? And I've got it in CSV form. Some of it I have in .rda form, which is the R's equivalent of .mx files. And so you can upload it in a variety of formats. If you want the raw data, you just, before I've cleaned it up and you want to do your own cleaning, good for you, you can go to healthcare.gov, and there's another chunk. Oh yes, to access these additional files. And so there are gobs of data down there. And so let me just tell you where this research is going. I guess that's the last slide that I have before I can, happy to take your questions, which is, no, that's actually, okay. I'm sort of prepped to do joining of various databases because I think I've now got the data in a fairly clean form, but I haven't actually done the joining. There's new data that should be available shortly, and I want to incorporate that, the sort of thing I was hoping to do for today, but I was thwarted by the data not being available yet. I want to do some machine learning, for example, to try and figure out what do we really mean by a PPO? What do those have in common? What sort of clustering characteristics? What can we predict? And then I actually don't know what else I'm going to be able to find out there. What we have is an unprecedented source. One of the things I guess I'm also interested in is data binning this data, so that if you're using Mathematica, you now don't have to do the semantic translation of state code to state. You can actually have it in there as a state, and therefore that will facilitate, you now want to correlate something with population density, okay? So you no longer have to go fishing for what is the population density of Oklahoma. It's built in, it's a property of Mathematica built-in data. So I think there's some utility in trying to make this data set as Mathematica semantically, I don't know what the right term is, a semantic import of this kind of data to facilitate greater study. So with that, I will stop